what I was excited about. I was like, oh, let's put on some jeans and a t-shirt and go see what's going on.
Go for it. That's what we need to. All right. So, threat hunting, web shells using Splunk. So, basically the agenda for this is why detect web shells. Then we'll go over some common web shells that you'll find in the wild. What do we need to hunt web shells? And let the hunting begin. So, why detect web shells? So, just in case you guys, this is kind of a basic before we dive a little bit deeper. Web shell, server-side compromise, generally results from either you can have an LFI or an RFI or some type of a weak admin panel that allows you a functionality of uploading something, and that's generally how it occurs. So the functionality of the web shell is really, it's all built into a single file, which is kind of the one of the great things about it from an attacker's perspective. So because of that, it's all in one file. It's very easy for them to hide and make multiple copies and things like that inside the compromised web server. And with it, it really gives them the ability to have command line access to the web server. Now, once they have that command line access, it's generally going to be, unless the server is extremely misconfigured, you're going to be having your like www type permissions on there, which is not really that big of a deal from their perspective, because then they have all the time to try different local exploits to privilege escalation, or they can simply keep the privileges that they have and try to work on pivoting into the internal network, which would of course give them even greater access to things that they're more interested in. And so the way that most of them work, you have a file that's on the web server itself, and then there's a client that the attacker has. The client is generally either, it can be something as simple as using a web server to connect to it, or in specific instances, the client is actually a piece of, it's like a GUI interface that they have running on their box that they use to connect to it. And we'll look at a couple of those coming up. All right, so common web shells found in the wild. Before we get into this, so there's probably literally only like a dozen, maybe even less than that, popular web shells. But what you'll find is it's very easy, even for script kiddies, to make slight modifications to those web shells, which really makes detection using signatures, either host or network, very hard, because it's like, if you're looking for, let's say, MD5 hash sums, you change one character, that is then changed. So in a couple of reports, and I have resources at the end that you can look up, they say that the detection rate on a lot of these from both IDS and AV is like under 14%. And there's a lot of instances where, you'll have that file, you'll run it through, you'll upload it to VirusTotal, 0 out of like whatever, 4751. Doesn't detect it at all. So, which is why, finding them in your network is very important to hunt for, because they can cause a lot of damage and they have a lot of capabilities. So the first one to look at is WSO. This has been around for quite a while and is really interesting because of the way some of the capabilities that are built into it. A lot of times WSO can be found as like, they will upload it and configure it as like 404.php. And if you were to visit it, it actually looks like your standard 404 page, except that inside the page, there's actually a hidden form to log in with your credentials. So finding it just by, going and coming across it, not really going to happen. I mean, you really need to know what you'd be looking for. So this, for instance, is the WSO admin panel. You can see that from a functionality perspective, these things can pretty much do them all. I mean, talk about serious damage. I mean, you have a file manager that you can look at, you can change directories, make directories, execute actual commands on the system. upload more files, write files. There's even, you can see here, so there's the console that will actually give you access to just start, it's basically remote shell. You can actually connect to SQL databases on the back end and start looking at SQL stuff, find more information about basically like your PHP INI file to find even exactly what PHP is doing. There's even the option to brute force other web forms in here. And then you also have the self-remove ability, which allows it to delete itself completely. C99, another variant. So this is a variant from WSO with a lot more functionality. And they look really, really similar, but no one knows for sure, like if it was, WSO came out and then someone just grabbed that and then decided to make their own variant, or how that works, or how they set that up. So as you can see, it looks like almost identical. There are more things in here. I don't know about this particular version, but like this one is from like 2016. And I'm trying to think, I think this one I actually got from, I mentioned the resource at the very end, and I'm pretty sure that this one comes from a Mandiant write-up. But I mean, as you can see, it's like this is all in this single PHP file. And these files are not, I mean, they're not massive. You're not talking about like 10 megs or something like that. You're talking about like a few megs. So, thinking about like where, you can see here, WP content, uploads, profile underscore pics. I mean, and what they'll generally do is, once they get this in here, especially like in, if you think about a WordPress default install, just to like, start looking at the, directory structure and how far down you can start to put multiple copies of this in there. And from an admin's perspective, when you're looking for these things on your site, even when you're going through all of these directories, all right, so 404 PHP, well, that looks legit. I mean, yeah, someone basically uploads it as c99.php. Okay, well then you're probably going to be like, what's that? What's going on? So that's what makes it a lot more like this. I mean, had they just changed that to something more human, it would be much more difficult to decide, well, is this, and then one of the things is that also if you, like when you just browse to it, a lot of the times, like we talked about the 404, like it actually hides itself depending on the, and a lot of them have this capability too, where depending on the user agent string that's connecting to it determines what it looks like. And some of them have no, although they have the functionality in there, when you view them from the outside with just a plain browser, they don't come up with any HTML. There's no source that you can see on it at all. So, which also makes it much more difficult. China Chopper. This is another really interesting one because it is used very often with APTs. There's quite a few active groups out there that use this. It is probably one of the most popular Windows web shells, and it's extremely small. The initial file itself is like 4K, and it has some really interesting, they all have, and they just keep on getting more functionality where, so let's say that you upload this into a particular directory, let's say it's just your plain www root or something. It can actually, it'll modify the timestamp so that it matches all the other ones as well. So if you're hoping to go in there and say, well, wait a minute, I did this install a year ago and yet here is, this file that was just uploaded today, that's suspicious. But when it modifies the timestamp, and it looks just like everyone else, then it's much more, again, it's much more difficult. So, China Chopper, when you connect to it, the client, there's actually a client itself with it, a GUI client, that the attacker is using from their machine rather than using their browser to get to it. So this is just an example of how they add more victims that already have the shell on there and how they'll essentially connect to it. So you can see here, it's like, okay, I want to go to this one here, shell.php, the password. they'll put it in here, and then of course they can, depending on the configuration, they can change, like, you can change it where it's not UTF-8, things like that. And so all those small things that are really easy, and you can see how it's using the PHP eval to actually execute the shell, execute the web shell once the client connects to it. So all these things can be changed, making it much more harder for your traditional IDS network and even host intrusion to pick up those types of things, because signatures just, unless they keep it absolutely default, does become harder. Now, that's not to say it's too hard, because to be honest, most script kiddies using these types of things don't change anything, which definitely helps us in our hunting with it, which we'll see in a little bit. Okay, what do we need to hunt web shells? First is we need data. We want to get lots of data. There are really two main ways of hunting web shells. You're either going to be looking at host logs, so specifically something like your IIS web server logs or Apache, or whatever web server that you have. And then the other option would be, which is the option that I generally go with first, is because a lot of places, you could have hundreds, if not thousands, of web servers. So going through those logs, all right. But I prefer to initially start off, because I kind of work my way down when I hunt. I like basically going network, host, endpoint. And so for our example, we'll be using our network logs from Bro IDS, because it's essentially my favorite tool. The way that we'll be doing that is we're actually feeding Bro we're outputting Bro logs into JSON, which we then send over to Splunk, and Splunk is ingesting them, so we can have the entire network-wide data, metadata that Bro gets in there to start looking through. But of course, this is really dealer's choice. It's really up to your environment and what you guys have. There are tons of ways that you could use an elk stack. You could focus specifically on actual web server logs. You could be feeding all those web server logs into Splunk. It's really just, it's really what you're comfortable with and how you want to proceed. Okay, let the hunting begin. Okay, so one of the first things I really like to do when looking for web shell activity, I want to look for successful HTTP post request. And the way that I kind of do my hunting and the way that I view it, I don't really want to query something looking for just like one particular thing. I'm really big on always trying to improve my efficiency. So basically kind of think of it as like every query I run, I'm really trying to, two birds with one stone. So if we look here and we actually go through the query, we have index JSON Bro. So this, of course, is my Splunk query, and that's my index. The event type, Bro HTTP, because we're looking for web shells. We want to look at actual HTTP traffic. We're looking for a post request, and I'm looking for a status that comes back that's 403 or under. So basically 403 to 200, that's what I want. And in the URI, I'm looking for a file that was with the post request that ends in PHP, JSP, CFM being Cold Fusion, ASP, ASPX. And the way that I'm essentially sorting that is like, hey, I want wherever the request came from as the source, show me the host name, and then essentially sort it by the URI. Because, and the way that I have it working is I want to look for successful obscure post request. Like, I don't want to look on my network, because we're talking about so much traffic. I don't want to look at the successful post request that has like 17,000 counts, because that's probably legitimate. I want to start with looking at like the single, like there's only one time that this happened, and there's only 2 times. And then I can start to see like, that doesn't look right. Because if you think about it from an attacker's perspective, yeah, they're not connecting to this thing 100,000 times, more than your normal applications on your network. So by starting it that way and looking for outliers, which is in threat hunting. I mean, that's essentially how I look at everything. I want to find I'm looking for weirdness on the wire. I want to find, the obscure things that I don't quite understand. So in this case, this is what it comes back with. So in this instance, these are all successful post requests. And you can see track PHP, get data, get hashes. Here's obviously a kind of default WordPress site. Here are all of the IPs that made the request. Here is where they were going to. So you can see here, this is obviously like an internal network. These are external hosts on the internet. You can immediately tell that, 3 IPs on the internal network going to all these hosts, that's probably all legitimate. Like even though there's only kind of like one apiece. Sci-fi.com, I'm a big nerd, so that just makes sense that that's going to be right. And then some of these other ones. Well, ESET, I know that that's antivirus. And I can see here, and it's, nothing really stands out of the ordinary. And especially for the first post request, and generally the first post to a web shell. And this is where I talked about it's twofold, because a lot of the web shells, when you log into them, you're seeing the post request. And it's usually not going to be something as neat initially here. I mean, they may move it over, but the likelihood that there's like a remote file include or an upload that you can do directly into the main, directory, not nearly as common as a very obscure, especially for WordPress. It's most likely going to be coming from like an old out-of-date plugin, which is going to be much longer, and you're going to look at it and say like, oh, that's, what's up with that? That's a little strange. So like I said, for instance, C99, which we already talked about, like this is the initial post request to C99. Like if you had seen this post request on the page before, you should think that that is pretty weird looking. Like it should immediately say like, okay, you have the question mark, or login. I don't really, port 55555. Like this is odd. Like this should draw your attention because, for me, this looks quite different. And then as you do more and more hunting across more and more environments, you tend to see the same things kind of over and over again. So, but for me, if I saw this, even if it was something else completely, just the way that login, I'd want to look at this. That's also an obscure port. Like I don't know exactly what this is, so I would want to dig in further to see what exactly was happening there. All right, so the next thing that I like to do, I love user agents because they reveal a lot of information. And the ones that I am looking for, out of date and outliers. So I put out of date first, but let's talk about outliers. So in the outliers, again, we're looking for those just single, like 1, 2 times, 3 times, 4 times, not 5,000 times. That's kind of where we want to start. And then by out of date, we'll get into that in a second as to what that actually looks like. So same thing here. We're still in JSON Bro. We're still looking for HTTP in the Bro logs. And the way that we have it set up here is stats, count by user agent, sort count, reverse, which that allows me to see that initial like 1, 2, 3. We'll look at that in a second. But if you look at this, I'm going to show you something that is kind of cool in a second, or a way of how to do this, because this is obviously a very short request that's really easy. But what I'll show you in a second is how to build off of that to get more and more specific. So just doing it plain like this is essentially one of the things I got back. Like this is a bunch of crap. And again, 2 birds with 1 stone. First, I'm looking for signs of something like a web shell, some type of malware, but this is good information. What is on my network? Now, some of these things may be completely legitimate, but maybe they're like legitimate, but they should not be on there. Like if you're on a corporate network and, you know, there's a lot of iPhone stuff on here. I mean, maybe you guys are, maybe you thought that you were, you know, that was on a different VLAN coming off of the wireless. Like this should not be coming off of the network that you are currently looking at. You know, then you have like things like, okay, yeah, someone's running an Apple TV. That's just not, these are bad practices. And this essentially adds tons of noise to my network, which makes my security and securing of that network much more difficult. So I want to know those things. Like for instance, like, okay, HTTP product.version. Yeah, I have no idea what that is. Like, is that malicious? I don't know, it could be. Like, I'm definitely going to want to look into it because it's weird looking. I mean, some of these things I can obviously tell, right? Like, I know that like, okay, well, my radar, yeah, that's an app on an iPhone, okay. And then we start going down here. And we start looking at the, you know, okay, so these are iPhones. A lot of these are normal when you deal with mobile, you start to see that a lot more. I can't remember what the OKHTTP, I looked it up and it is like, okay, that's like, whoever wrote that app is a moron, but you know, still it's legitimate. So as we keep on going down right here, now we get to these ones right here, and the one I want you to actually focus on is this one right here, Mozilla 5.0 compatible, MSIE 10, Windows NT 6.1, well 64 tried it. All right, so this is showing a typical, you know, IE10 web browser. So if we were to go back here, right after the HTTP, if we did space and then we did something like MSIE, it would come back and show us all the, you know, supposed Microsoft Internet Explorer user agents on our network from, you know, the least to the most seen. And you can actually get even much more, and so this is where you start actually expanding this query to start looking for more obscure things, like let's say you put in something like Opera, like, you know, is it normal that any of your users would be using Opera? You know, maybe not. So that's where, you know, you start to look through these things, and it's very easy, even from a, you know, someone who's not used to hunting. And that's one of the reasons I kind of wanted to show it this way, is just to show how, like, it's not difficult. People ask me all the time, like, hey, I want to be a threat hunter. How do I start? Start. Like, be curious and just start looking. Because start with one of these types of queries and just start building off of it, because, you know, the data is kind of self-explanatory. Like, yeah, you need to look into it further, but it really gets your curiosity. You can see like, well, hey, maybe I should start looking for, I want to know about this, or I want to know about that. And, you know, I could talk hours about user agent strings because I've used them for years, and I still do for web application testing and things like that. Like, I love using all my scanning I do for web application sites. I almost always scan them as a Googlebot, because almost no company, e-commerce site, yeah, they'll literally never block that because they want to be indexed by Google. So they allow that well, you know, way more open than they do other ones. And they also don't think about it, they don't see it as suspicious even when there's a tons of requests behind it. So, all right, so we showed this here. And like I said, I want you to remember this MSIE 10 Windows 6.1, because this is actually a, this is a legit one. But, okay. So now we're talking about out-of-date user agents. So the really interesting thing is China Chopper, which we showed before in that GUI, the default user agent string is Mozilla 4.0 compatible MSIE 6.0 Windows NT 5.1. And when you look that up, that is the user agent string for Internet Explorer 6 running on a Windows XP machine. Like on your network, if you're running Windows Internet Explorer 6 on a machine, you probably have some issues. You're going to want to look at that machine. Either it is something malicious like this, or that machine is very out of date, and you need to, you need to send that up, and you need to locate that to, to get rid of it. Like, why would that be on there? That's just not a good thing. And so, like I say, I mean, that's why for me, when I go to a customer, regardless of the size, it can be, a mom and pop place down the street or a Fortune 10, $100 billion company, you still see these things. And so there is no such thing as a failed hunt, which I kind of hear a lot about, like, well, we didn't meet the objective was this. But the way that I hunt is, to me, the whole idea behind hunting is, of course, providing value, just like any other security engagement. So, even if I wasn't able to find a particularly malicious user agent string, coming back with like showing the assets that are so old and out of date, and I can guarantee if I were to show this to a lot of my clients, they would have no idea that it even existed. But they'd want to know that because, yeah, even they would be like, yeah, we need to get rid of that. What is this? Why is it here? I mean, I've seen these types of machines running in data centers that handle credit card transactions that someone plugged in one time 5-7 years ago, and no one ever knew about it. It never came across anything, and but they they're immediately like, we need to take care of this. So that's value, and that's kind of why you're always looking for, what's just not right here. And like I said, user agent strings are a great way to do that. One of the next ones, basic authentication. Again, same thing, Bro HTTP. But this time, we're looking for username. Same setup as before, but we want to see, all right, is there any web request that we have in here where it's using basic authentication in the application itself? Because in any environment, you should not be able to get results out of this. Like, that's just not, this is very old. Basic auth. And yet, here we go. All right, this is a login. These are actually 2 logins to a Splunk app. And as you can see here, username equals Splunk and password equals Splunk. You would want to know this information. A lot of the web shells provide simple mechanisms to authenticate. Things like basic authentication, digest, very, very old and common things. So looking for that, because the truth is if this was something else that was, even if this is, or let's say that this is a legitimate application, which of course it is. I mean, all right, this is Splunk. Well, this should definitely be on SSL. It shouldn't be running over HTTP. So we want to look at that. Like, why is this? Again, I would say that if this had been run at Equifax, I think they would have found some interesting things and been like, what, this is probably not best practices. How do we let this into production? This is just not, this is bad. So I will say that that is essentially the end of it. Like I said, I really just wanted to start any one of these. I mean, we can literally dig in for hours. Because there are so many ways to use something like user agent strings in multiple areas in the kill chain. And I mean, any one of these. And so, without knowing as far as the, you guys, where you were at as far as, hunting goes and in Splunk, I really wanted to show you like, hey, even with these simple queries that you can, just by looking at them, you can spend 5 minutes and start to build off of them and find some really great information. And it's not difficult. So all you need to do to get started is just start. And by doing that, I mean, you will learn and you will see a lot of things that provide immediate ROI back to the company. Here's malicious stuff, and here's stuff that from an audit perspective, we would fail on. So here we go. And by being able to do it that way, you have less pushback as to the value that the hunt team is providing, because essentially they're always providing value, and that's really the way that that's really the way it should be. Yes.
So I've done something similar before, but the challenge that I had is we had so many different appliances and endpoints and usernames.
I was going to say, the one challenge that I come up
about is like essentially APIs essentially use their own custom user agent strings
Yes.
now even. So, but I've got a trick for you on that. If
Okay.
we continue.
Yeah, so basically I have 20,000 records that are one each. And so how do I sort through all that when there's that big of a tail on the data?
I mean, are they all similar but just a little bit different coming back that way, or they're all completely
It's
different?
a little bit of both. Some of them are similar, some of them are completely different.
Sure. So the one way that I found, especially with Splunk, is you can essentially leverage like lookups or KD stores essentially to either catalog
Okay.
list of things that you know are things that you want. So essentially you can use those to filter out in the future. But more to the point of that you can use those to get pre-populated lists, because there are hunters like James and like I know I have my own like sets of ones that essentially carry like huge list of user agent strings, and you can either append additional metadata to them so that you can like have notes on it and then do a lookup against those user agent strings. I would advise you not do it like at the very front part of that of a
No.
query in Splunk, like user agent bro and then
Yeah.
bro and then input lookup or or lookup that way, because essentially you're gonna append a bunch of stuff. But after you stat it out or you do distinct counts or something like that, essentially what it'll do is it'll allow you to see anything new that it'll identify a couple of things, something that you haven't seen before. It'll allow you to go through so you can populate that way, something that somebody else may not have seen before if you're aggregating these lists from other places. But you can also categorize them. You can say, I don't care about stuff that's just out of date or vulnerabilities, like you can tag Java user agent strings and things like that to identify outdated browser agents and things like that way. Or not just browsers, but actual applications, web applications.
And one of the things, if you're looking to do that, do lookups and categorize things from like user agent strings, there's some great resources online that like actually user agent strings. I wouldn't say it's either user agent hyphen strings, or I can send you I use it all the time. I'm just drawing a blank on what it is.
Essentially lists that are curated that can help you filter out a lot of that noise anyways.
Well, it'll actually, it literally provides a constant update of user agent strings from everything from browsers to crawlers to devices to things like that. So it's very easy to look at that. And like I said, this is not like, hey, you're going to do this once and you're going to run the same query, every couple of weeks.
Yeah.
No, the whole idea is that like you start to weed that down of like, oh, I know what this is, so we're excluding that. Or like, for instance, you may have a lookup that says, I want to categorize what like every Windows Internet Explorer, user agent by like we showed here, like IE6 on a Windows XP, so that when I basically compare it, I know exactly what OS is running all these things, and I know what I should be running, so I can exclude all of that stuff. And it's very easy after some time to even take a massive list and start to get rid of, or start to exclude a lot of the things that you're looking at, so that you can focus on the more juicy pieces.
It's a bit more advanced than like what James would have time to do today, but like going into some of the entropy and
I have real challenges with trying to use Shannon entropy with current like AWS CDNs and everything. It's just like G00 dot.
because they're all dynamically generated.
Yes,
and
yes,
it's
exactly.
essentially-
Yeah.
so
And we didn't get into it, but like from a web shell perspective, it goes like I said, this is really just like the surface part, and we could talk about this for several days, because one of the things I like to do is entropy. So an interesting thing is when you start to look at request time for particular files. It's so, because what will happen is like the web shell, like we talked about, there's tons of functionality. So when you start looking at the actual completion request time, it's much longer than. And so it's a really interesting way to see like, well, wait a minute, I have this user, profile avatar, I have a PHP file in there, and it's like, it takes 15 times longer, to complete than, the application does. So either that is a huge, if that file is legitimate, then that's an issue with the actual file itself. Like that's a bad development right there, or that's malicious. So I want to focus on that, and I want to start digging into it to see, what. So, I mean, there's just tons of ways to do it. But like I said, I mean, I wanted to give you guys just a quick intro to start, because initially when I start, I mean, that's what I did. I started these simple queries that I could know, and because I didn't have any Splunk training, so it's like I would I would find one that was like easy, and then I'd say, oh, well, hey, well, what if I, let me look at it this way, or let me change how I do it. Say, well, and then when I came across things like, reports and, threat intelligence reports, and they would have something in it, I'd say, oh, well, okay, let me go back and see or how can I cut down the huge amount that I have here into something that's much more manageable that I can do because, that's the thing about threat hunting, is that every one of your hunts needs to end in an updated policy or procedure. Like you shouldn't be doing, like if you're doing the same thing each time, then you're not hunting correctly. That's how we get better and better and faster and more efficient, is by saying, okay, like maybe we do, categorize these, and then maybe we start to say, well, yeah, well, we know that those iPhones shouldn't be on there, so we're going to segment those, that should be in its own VLAN over here. So when I look at this, then that could take away, and when you just do that on a handful of things, I mean, you can
essentially those should turn into those should get handed off to your detection team or something like that. Say, here's the signature, here's what you need to go look for, and you guys need to be responsible for that now. I guess is that kind of what you mean? Like, essentially, you're going to find something that it turns into something actionable for the organization.
Well, I mean, essentially that's what you're hoping, but you need to be able to cut down through the noise. So what you'd really be doing, I mean, this is really an IT problem. Like, why is it like the network configuration is incorrect?
Yeah.
Like, how we talk about all the time. I can't tell you how many clients that we've been at where it is like, oh yeah, we have, this is air gapped. It's like, no, this is not air gapped, because you can see it right here. Like, and it's like, but that's not a security issue. That's, that's an actual infrastructure misconfiguration that you guys need to change. And when they do, then, this potentially cuts down in half. And so it's like, okay, well, now it's easier for me to sort through this, because then I can look for more specific things. And it's just that process that you repeat, but some change is being made afterwards so that it's easier to identify legitimate and, as opposed to malicious, that you're really looking for. Because that's what you want to be spending your time on. I mean, it'd be great if you could just find malicious, and then, send it to, your senior analyst or however your organization is, handles those things. And that's really where you want to get to. All right. Well, thank you guys very